Welcome to Experience dormakaba, an opportunity to hear directly from those who are either presenting or benefiting from the advanced solutions that dormakaba has to offer. On today's episode, we'll be talking with Tom Chaney, the lead product manager for entrance systems at dormakaba, about selecting the right operator for your needs. Thanks for tuning in. Thank you, Tom, for joining us. First of all, just tell us a little bit about yourself and your role at dormakaba.
My name's Tom Chaney. I'm the lead product manager for entrance systems at dormakaba. That covers the product lines of revolving doors, swing door operators, automatic sliding doors, and then a variety of entrance systems controls in our physical access systems category.
Great, Tom. So what does someone need to know to pick the right swing door operator?
In a practical sense, you really should start with frequency of use, traffic volume, conformance to codes, and standards. I would really suggest that you kind of look at every opening holistically. I think that's one of the things that's most often missed. So what do I mean by that? When you look at a door from a holistic perspective, that means you're going to comprehend it as something that's really intimately interconnected in all its reference points, and you can really only explain it as a whole. And so you can't just look at a few aspects like the door weight, which is a common mistake. You have to look at how all of its aspects work together. So the only way to assess it is the circumstance that forms the whole setting for the door, the operator, and its operation. So its width, its height, its door material, weight per square foot, how the door is hanging, arm geometry. Is it for egress? Is it fire rated? What's its primary usage? And then really at the end is will it fall under a specific ANSI standard? In this case, an ANSI 156 standard. And then what are the prevailing conditions at the opening that affect all those other factors?
Okay, great. Now, that touches a little bit on my next question, and perhaps you can elaborate upon it. How does frequency of use and traffic volume influence the decision?
So doors that are going to be used manually for most of their cycles tend to require an operator where people expect to have an easy manual use. So we have operators like our ED900 or ED50 that do have that configuration. So it's mostly manual use, but the operator is still robust enough for regular low energy automatic use. And then you start moving into sort of the next category of door openings where you have high frequency operation in the low energy or knowing act application, and some of the full power, which is activated by a sensor. So the one ED100 that we have, that's addressing the market. So you have a very flexible product for common door sizes, weights, applications, but it's really sturdy enough to be outfitted for the higher frequency and forces of full power, which allows the door to move much faster. So if you have a large, heavy, or challenging door, or you're going to have higher frequency full power operation, then our ED250 becomes the top highly capable solution for a reliable and intuitive door control in that application.
Okay, Tom, how do the building code and ANSI standards factor in?
Most of the authorities having jurisdiction, which is a local authority, have adopted a version of IBC, or the International Building Code, that includes an ANSI safety standard. These standards govern allowable speeds, forces that the operator can move the door at, as well as safety equipment that is required by application. So there's two standards that we have to consider along with the respective IBC requirements. The first one is what we call .10, which is ANSI A156.10. That is the standard for power operated pedestrian doors, and that is full power swing doors that we're talking about, or full energy also, and then your automatic sliding and folding doors. The other standard that people are probably most familiar with seeing doors of this type is the ANSI 156.19 standard for power assist and low energy operated doors. And that covers doors that operate at slower speeds, low kinetic energies, and they're commonly activated by a push button. And the standard actually states that it must be activated by a knowing act. So you would not have these as sensor activated. So don't let the full power versus low energy monikers confuse you. It has nothing to do with electrical requirements. It's just really about kinetic energy that the door can move at. What you see in the full power doors are high frequency doors, typically one-way directional traffic. One door is going in, and with the other door, another door would be used to go out, because the industry, as a general rule, really doesn't support full power for two-way traffic. It is allowed in the standard. It is not recommended because it's clearly just not as safe as a one-way application. But these doors are allowed to move at higher speeds, and they're going to employ monitored sensors and rails around the door for safety. The low energy operators, they provide accessibility for physically handicapped people, as well as allowing ordinary pedestrian traffic to use the door manually. It's really more appropriate when the traffic flow is lower. Slower speeds don't have an impact on user flow. And it's also common for these low energy operators to be applied to existing doors to improve accessibility.
How has the pace of technology affected swing door operators and customer choices?
Now we have more advanced computer systems and software in these operators that will improve door behavior and control. Many of the older operators out there have PLC systems or solid state controls that have very, very limited functions. So your ability to deal with opening conditions or behaviors you want to achieve are very, very limited, because the adjustment variables in the PLC or the solid state control become either ors. They don't have the range that software controlled operators do. So if you compare the capability of your handheld calculator of the 1980s versus modern PCs and modern electronics, that really is the differential there. So the industry and the technology is starting to move into networking these products, having predictive aspects for maintenance. And in some cases, the sensor technology is beginning to move into predictive behavior, as well as anticipating approach vectors of users.
What are some of the common pitfalls a customer might experience when making those decisions?
The number one we see is considering door weight only. The door weight is certainly matters, but door width and height are also influencing factors, particularly in light of building pressure and wind conditions near the opening. So oftentimes people will look in a catalog or a piece of literature, they'll see the door weight, and they'll draw conclusions from that. But not having a clear understanding of respective requirements under the ANSI standards and how they affect the equipment you choose, that will ultimately affect how the opening is going to operate. So there's also wide misunderstanding about the allowable activation methods, as also how fast the door may move, speeds and forces. There are also operators out there that don't measure kinetic energy of the door during setup. They can be adjusted to exceed allowable speeds and forces. And in low energy, that's without all the safety equipment, that's a real risk for the user and a liability risk for the owner. So it's really recommended that you take a look at all those aspects again when choosing your operator, and then have it installed by someone that is ADAM certified. The ADAM organization is an industry organization that has a certification program for your understanding of the ANSI standards. So you're assured that when you have someone that's certified, that the operator is safely commissioned so it complies with codes and standards. So the other primary ones are not considering the building pressure or wind conditions and applying the appropriate hardware, and then having unrealistic expectations of door behavior when you don't take all these factors into consideration.
Great, Tom. Well, I appreciate all of this great information. Thank you for giving us your insight today.
Thank you.
Thank you for listening to Experience dormakaba. To learn more about the solutions we discussed today, please visit dormakaba.us.